What's up, everybody? Welcome back. Today we are working on adding user accounts to our Rube Goldberg machine website. So the context here is we are working on this Rube Goldberg machine, completely virtual, right? Where basically like the environments that these balls are going to move through are like completely defined by WebAssembly modules, and that means that since WebAssembly modules are pretty sandboxed, we should be able to like run user uploaded modules on our server to do like our physics simulation long term, without worrying too much about like security vulnerabilities and stuff like that. But yeah, anyways, the point is like these platforms are moved by like WebAssembly modules, and when the balls bounce off the platforms, like the response of the balls is also handled by the WebAssembly module. So the idea is that users will upload chambers, and the balls will flow through all these chambers, and we'll maybe get some like interesting behavior out of that. At the very least, it'll be fun to look at. And so for people to be able to upload chambers, they need to be able to be identified in some way. We need to be able to like say, okay, this chamber was made by this user, as well as maybe like give them a little interface to like add and remove things, update things, whatever, right? And so we've been kind of looking at for the past few days about at this like OpenID Connect thing. And it's a little complicated. But we're starting to get the pieces in place. So my understanding at this point is that we have our web server, spheraphoria.dev or something. We serve you some web page. So this is going to be like client. And our web page is going to have like a little like Twitch button on it, or it's going to say like log in with Twitch. Log in. The user clicks this button, they gets redirected to Twitch's servers. We'll put Twitch over here. Twitch. So they go over here and they go there and they give it some parameters that we told it. We're like, okay, tell it that it's us. Like tell them we want access, and like tell them to send you back over here when they're done. And so they give you like this code, and they like kind of like redirect you with that code back to our server. And once we have this code, then we can do some like interactions with Twitch to try to get like user ID info. There's like some like intricacies here where like the ID token is this like absolute fucking disaster of a thing. Let's see if I can pull it up. So like this is an example of an ID token, and this is like this JSON web token that has like a header and a message and a signature, and you're supposed to validate the signature by going back to Twitch's servers and asking them like, oh, what's your signing key? And then like doing some like RSA verification to make sure that it is what they say it is. There's like some like information in here where they tie back the request. So when we send to the client, we give them like a special number, a nonce, and they send the number in here, and the number gets like encrypted and sent back to us here. We need to like do some sort of like state management to make sure that like when the client makes this first request to us, it's like, can I log in, please? Then they close their TCP connection, right? Because we have like, there's no guarantee that like connections are going to be reused. And in fact, on our server, there's a guarantee that there will be no connection reuse, which may change in the future. But at this point, that's the case. So we need to like have some sort of way to identify, okay, when they come back to us with this code, how do we know who they are? Stuff like that. So there's some stuff to get into. But we've kind of like got a lot of like the pieces in place, and today's topic is to try to like actually run the flow. And so I think the plan of action is like, let's make like a dummy login page. Let's try to like get the client to go over to Twitch and come back and like have us understand who they are. Let's try to figure out who they are and validate that like it's a valid response. And then hopefully at that point we'll just have like a logged in user. That's the goal. That is the goal. So we are 4 minutes into stream, and let's just kind of see what happens. So I think what makes sense is we have like our like general application, and I don't really want to do all of this experimentation there yet. I want to do it kind of like in its own sandbox so that it's easier to focus on the parts that we're trying to focus on right now. And so I think that I want to spin up like a new HTTP server in this like user info file program. So right now our user info program, zig build, zig out, bin user info. It just like prints my name because it like takes these hard-coded things that we got as like an ID token, from our like hand-rolled example that we did a few days ago, and make sure that we parse it correctly. So we can just like extend this to actually do the authentication flow. The way we have our HTTP stuff set up right now is we have these like event loops, and we need to like register a HTTP server with that thing. So let's pull an example from main. So I think that what we do is we create a TCP server, and our TCP server listens on some address, so we can just kind of copy paste that as well. So we have some address. We are create a TCP listener to thing. We're gonna say we're gonna be unconditionally on port 8000 for now because that's fine. And what we feed the TCP server is like when somebody connects to you, what you are going to register a new connection with the event loop. And what is that connection going to look like? So we have to create that interface. So I believe that we just need to make something that's like a connection spawner. And we probably want to connect that to like some sort of like server state. So I'm going to do like const server is equal to some struct. And he's going to have a spawner that gives us a TCP connection spawner. So this is going to come from, I guess, TCP server here. And basically, he's going to create these like generic objects that can be fed into the event loop, and that will, when the event loop sees traffic on a given socket, it will call our handler essentially. Right. So we need a handler, which we have an example of here. Is this right? Yes, this looks like an example of what we want. Okay, 1 second. It got really warm in here. It was like a second ago, so I'll just be right back. I'm gonna switch to t-shirt. Muted. My bad. What's up, everybody? We're back. Okay, so our connection, he's basically going to wrap some sort of like HTTP connection. We are going to, every once in a while, when he finishes reading something, we have to like generate a response for him. Which I guess for now we're just gonna make like a dummy page. Let's do that. Maybe we'll say const index is equal to what, doc type HTML head body hello world body. Okay. Which means that here, when we want to generate a response, it's just like our header is a HTTP header with content type is HTML. The status is going to be okay. And oopsies. The length is just going to be the length of server index HTML length. Okay. Then we can just say that we have response is a HTTP writer initialized with our allocator, which we don't have, so our server needs to maybe hold an allocator somewhere. Which means that we have a reference to our server, so we're chilling. We give it an allocator. What else do we need? The header, the body, which is just server index HTML, and we are flagging that that is a non-owned reference. And then we're chilling, I think. Does this have to be like, is this available? Yes. So we'll just do, I guess what we did here, catch return dnit. Yeah. Okay. Okay. Yeah, seems good. So then we just run our server. So here it's gonna be, we need to make our server. So this is going to be server is server initialized. Do we have an initialized? No, we just feed him. We just say server with alloc is our allocator. Boom. And there we go. He needs to call, he calls spawn in here, and we didn't actually implement that, so we'll just quickly do that. So when we spawn new connections, I guess it is going to follow this API. So function spawn, he takes in, not this, he takes in a self as a server, and he's just going to make a new connection. So const connection is equal to try connection init with self and the stream, and then we return connection handler. Boom. Simple. It's simple. Okay. So can we run this thing? It's fucking broken, of course, because he wanted this to be non-const. Reasonable. This also wanted non-const at 412, so here we want var server. Okay, we didn't run the event loop, so we just do event loop run. And I guess we have to register the TCP server as well. So here we're going to register TCP server dot something. Hello? Why is my autocompletion not finding it? This is server stream handle, I think, as well as TCP server handler, probably. Does this thing need to be tribal? Probably. Okay, so now if we go to localhost 8000, we see our little hello world. We are chilling. Our server is set up. And so now I guess what we want to do is we want our server to have like a link in it that will redirect the user to the Twitch login page. So I think we need to generate some stuff in this scenario. So let's see. In this OpenID Connect thing, if we look up nonce, well, okay, actually let's start maybe on the Twitch page where we can just kind of like scroll to the bottom of this thing and work through the like copy paste some of the examples. So we are working on the authorization code flow example, and this is kind of like their example thing. So we can just kind of shove this in here as like a link, and let's just kind of start there and move our way forwards. So here we can just kind of be like link, simple, and then what is it? href equals this. Is that how you do this thing? Okay, so our client ID, I'm just gonna leak everything, which is fine. I've renamed the app do not authorize this. So do not authorize this. We're going back to localhost 8000. Scopes, we only want OpenID, I think. Claims, I think, is optional. State and nonce we have to generate. So this part's the tricky part. But we'll come back to this in a second. I just want to make sure that if that this is punched in correctly. So if we go here now, we need some text on our link, I guess, huh? Log in with Twitch. Refresh, refresh, refresh. So if I click this, let's turn on force verify equals true. Because I think that I verified the other day. There we go. So, yeah, there we go. Do not authorize. Do not authorize. And then if I click this, it should send us back to the same website, but now with like a code that we can use to ask Twitch for information about ourselves, which is cool, Okay, so we need to like set up a handler for that thing, right? We need to like look at the response and say, well, actually, first we need to generate this like state and nonce thing securely. And in this OpenID Connect thing, if you look up, what the fuck are you supposed to do with nonce? They give an example here where, hello, is it not? Am I in the wrong thing? I think I saw somewhere implementation details nonce. I could have sworn it was this one. OpenID Connect implement. Yeah, it must have been another one of these things. Let me see if it was in which spec it would have been in. OpenID Connect basic claims core. Maybe I was looking at core, or maybe I was looking at a new version of the spec. Let's look at this. Oopsies. Let's get the HTML version and see if this has the thing I was looking at earlier today. Implementation considerations. Yeah, this is what I was looking at. So they say here, basically, when I give this nonce thing to the user, I need to have some way of correlating whose nonce belongs to on the way back. And they're saying, hey, what you could do is you could store it as an HTTP only session cookie, store a cryptographically random value as a session cookie, and use a hash of that value as the nonce parameter. So basically, I don't have to store anything on the server side. And I was trying to figure out, like, what the hell is the attack model that protects? Because, like, if the client has both the nonce and the random number, then it being like a cryptographically secure hash doesn't really matter, because if I'm scared of them doing something fucked up, they could just change the number and change the hash because they have both, right? They can just rehash the new number because they know that I'm using like SHA-256 or something. But if I understand correctly, the threat model is more that there's like some attacker has somehow got like cross-site scripting or something, and so they're like in the JavaScript of this page, and they could, from that JavaScript, extract the URL that I'm sending to the authentication provider, right? And they could maybe like hijack that and be like, oh, I'm gonna like shove something in the middle. But if they shove something in the middle to say like, hey, redirect me somewhere else or something, like anything they do is going to, how do I say this? No, it's not changing. They were talking, I think it's replay attacks is what I saw somewhere. So they could like maybe like try to use this same request like from their website or something, from their browser or something, and gain access to that user's account if the user has like said we're allowed to access it. But they don't have access through JavaScript to the HTTP session cookies, and so they cannot they can't like take that request, execute themselves, and send the answer back to me and get access because they don't have this cookie. If I use this cookie as a way to like tie the user back together, something like that. It's pretty shaky. I didn't explain it well because I don't really understand it well enough. But I mean, the fact that they're saying that I can do that here seems reasonable. I thought that I was gonna have to store something on the server for this section, and I was worried about like people like unauthenticated just like spamming me with requests and filling up my memory. But it turns out that I don't have to worry about that. So they're saying generate a cryptographically secure random value, which means that our server has to have some sort of like random number generator that's cryptographically secure, which I think the standard library provides. Rand dot, I think it's this, cryptographically secure random numbers. Perfect. So we need a random number generator, and I guess we'll start there. So in our connection, instead of just hard coding this response like this, we have to generate a random number. So on each connection here, we have to generate random number, set random number as HTTP only session cookie, then hash random number and use as nonce. So how do we want to do this? I'm thinking that what we could do is, instead of like embedding this like state in this link, I think what probably makes sense is for this link to actually go to like just like login, like Twitch login or something, right? And then what we could do is why is it like so slow when I save? What we could do is then we could give them back a redirect with these parameters. Right, so let's kind of start there and see what happens. So we're gonna have to make some sort of like change in behavior based off of which URL they get. So maybe what we could do is we can make like a generate response. Generate response. And this is going to take in self. and he is going to do something. He's gonna do something. He's gonna make a HTTP writer, because this is how we like flag that thing. Maybe this is failable. Makes sense. And we're gonna look at the request that they sent us, and what URL were they asking for. And we can maybe like try to match that to something. So we can say like const URLs, or I guess we'll call it URL is an enum, and we'll just like say like, okay, so you could be like the root, or you could be Twitch login. Those are two options right now. And so then we can say like std meta enum string to enum of URL. And if this thing is not any of the URLs we support, we tell them to fuck off. Simple. I guess maybe we'll also give it index HTML. That feels reasonable. It's fine. It's fine. Yeah. So, or else we just return error and not found. That's what we're looking for. Not found. Okay. Then we can do something like switch on the URL, and if it is the root, we return whatever we were doing down here. So this comes from here. Boom, boom. Yeah, we return this. And if we get Twitch login, we have to do something special. And for now, let's just make sure that this stuff's hooked up right, so we can do something like just return. I guess we'll return something else. We'll just say const response body, and we'll say you're gonna log in, boy. So this comes from now it's body len, and this comes from body. There we go. And so I guess we need to actually call this function somewhere. It's crazy, I know. So we're gonna say try self generate response, and I guess having that catch d in it seems pretty reasonable still. So self generate response, catch e, d in it, set the response. Boom. Okay. Fuck. Because we need to make that RNG that we gave to the server. So somewhere we have to say like var RNG is equal to std rand default c spring. Do I have to initialize this thing something? Secret seed. So this is secret seed length u8. So how does this work? This needs to be 32. So I guess we just like std POSIX random. No, std OS Linux random. POSIX urandom? The fuck? I could have sworn there's like a get random. Get random. Okay, so we're say seed is, I forget already, it was I think a constant in here, secret seed length, yep. Okay. And I can't say equals like this. This is, I set the type here and I say this is equal to undefined, boom. Then let's get random into this seed, and then we initialize the seed. Chillin'. And then just RNG is equal to RNG. This can be const, I guess. Now does this build? Hell yeah. Okay, so if we go back to our website, not found, because we are going to the wrong thing. So there's 2 login with Twitches there, which is annoying. Let's fix that. So this one I'll just kind of like throw over here and comment out. So we're gonna need that URL in a second. I just don't want to have it there. So when I click this now, you're gonna log in, boy. Let's go. Okay. We are now correctly parsing URL targets. Solid. What's up? Recently switching from VS Code to NVM. Any tips on how to get smoother with it? What's your favorite, most commonly used key combination? I think, let's think. The dot key is extremely useful. I think that's probably like the best one. So like you do some action, like change in word, CIW, and you type something, and if you hit the dot, that'll like replay that wherever the cursor is. So I use that like all the fucking time. Getting familiar with like just searching is good. You know, body, next. But I mean, I don't know. I've been in it so long that I don't really think about it. Right? It's like if you ask me like, do you have a favorite word? I'd be like, I don't know. I say a lot of words, man. Like when I talk, I don't know. Yeah. So I don't know. Okay, so this guy needs to basically generate a redirect, and I don't really know. I don't think that we support that in any way, shape, or form. But it should probably be like if we send a status. Is there not like a redirect? Temporary redirect, permanent redirect? HTTP redirect. Let's kind of see, because I don't really know what the fuck I'm doing. Okay, so here they're saying move permanently, permanent redirect. I kind of want it to just be like, I want you to go over here now. This isn't like redirect decision. Temporarily unused, used to redirect. 303, that sounds right. Right? So that refreshing doesn't return. Yeah, what are our other options? Found. What's 302? HTTP 302. Redirect status indicates that the response request has been temporarily moved to the URL given by location. Browser redirects, blah, blah, blah. Therefore, recommend to set 302 only response for. Okay, so that's not what I want. That's not what I want. See other indicates the server is redirecting it to a different resource as indicated by a URI and location. That seems like what I want, right? 303. If I'm like just go over to Twitch for login. Yeah, that sounds right. That sounds right. Fuck it. Fuck it. Okay. So our server is going to say, fuck. It was 303, which is see other. And I don't really know what like the body of a redirect is supposed to look like. I assume that we just like shove the URL in the body. This is so. Just show me the HTTP request. Is there like an example? Ugh. Is not needed. Okay. So where do I put the redirect? Is it just like in the first line? HTTP redirect location. Where does it go? I see. Location response header. Where are we going? I see. So here I should be able to, in my header, we need some way to specify like redirect location. Right now we kind of just have everything hard-coded here. I think that, how do I want to handle this? Let me think. So right now we kind of say like, hey, we have this like header and it has these fields, and we are going to like just assume that that's like the only way we can write a header. But I guess what kind of makes more sense is like we could kind of build up any arbitrary amount of headers. And like there are a few ways to do this. We could like make a dynamic array and like push things into it as we go. But you could probably do it completely without heap allocation if we just said like extra headers, which is the same way that like the standard libraries version of this thing does it. And I think that makes sense. So we'll just say like header here, except we want to say that this is like a maybe like how do you say what this is? Like key fields. Field. Sure. That seems good enough. I don't know if this is the right terminology, but I don't really give a shit. Okay. There we go. So here, we'll just iterate over each extra field. So we'll say at the end of this thing, we'll put our last blank new line to flag that it is time. It is time to go to the body. But before that, we're going to iterate over our extra fields. So for self extra field, we can just kind of do this. We'll just say writer print this. Yeah, that's straightforward. Super straightforward. Writer print key value. That's going to be field key, field value. Which means that here now we should be able to just say like extra. I guess we should default value the extra thing so that everybody else doesn't have to change anything. So this is just going to be extra is equal to this. And then here we can just say extra is equal to. We need a new field here. So field. We have dot key is equal to location. And value is equal to. I guess we just give it this shit show. For now. We will fix this in a second. We're gonna have to like build this URL in some way, but for now we'll try this. Yeah. And the body is just gonna be empty. So the content length here is 0. Or can this be null? I forget. No, we have it just hard-coded to 0, which is maybe bad. Maybe we should just not specify, but this is fine as well. Okay, let's see what happens if we do that. Fuck! He doesn't like writer.print, where the fuck this is. Oh, because I'm supposed to put these in squigglies? There's no variadic functions in this language. Just tuples of unbounded length. We need to write try on this thing because it can fail because like the socket might be closed or something. Who fucking knows? And then 359 in user info. Is this supposed to be like this? Expected type field found 1 field. Really? Oh, is it because I didn't write const here, so it can't coerce that way? Much better. Much better. Okay. So we go back here, we click login, and he redirects us. Look at that! That's kind of slick. It worked. Look at us. We're like real web developers. Look at that. Gives us a little see other. Nice. Okay. Okay. So now we have to basically like generate this on the fly. So we probably want like our client ID and secret to not, or client, I guess we don't have the secret here, but it would be nice to like not hard code this stuff in there. So maybe what we'll do is our server thing object, we'll kind of hold on to like client ID and the client, we don't need the client secret yet. And here we're just gonna have to do like, okay, let me double check here. I don't think that we store this header anywhere. No, we just serialize it immediately. So we can just do, we can like be as creative as we want with like the generation of this URL. And so let's just say that we have like a URL buff. And we'll just give them like, I don't know, like 2,000 characters. Is that too many? How big is our stack usually? Like Linux default stack size. Like it's like 16 kilobytes or something, right? Oh, 8,000 kilobytes. Okay, we got plenty of fucking room. Okay. Plenty of room. 8 megabytes. Yeah, okay. So I've got 2K. I don't have to worry about this at all. Okay. I can never remember because like I hit Stack Overflows occasionally, but it's like generally because I just like unboundedly recurse. But then in my head I'm just like where like I can never it feels like it's small enough that I hit it, but it's only when I do something fucking stupid. Okay. So if we print into this thing, we print into it something that's going to be of this form. And let's just kind of start working through it. So this is all fine. Response type code, client ID. We're going to replace this with the client ID, which is coming from self server client ID. Yup. And this is going to go into the URL buff like this. Boom, 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 boom. And then const URL is go this. And then we can just kind of like slurp this into here. Boom. I guess we'll call this redirect lock. Redirect location. State and nonce have to be generated as well, but we'll get there in a second. Let's just, incremental progress. Incremental progress. Missing struct field client ID. So here, we can hardcode it here for now. I'm okay with that. And that comes from id.text. Yup. Yup. Redirect location at 365. Right, so this is failable, which means that this has to be tried. Boom. And then here we go back, log in with Twitch, and we're still working, so everything's happy. Everything's happy. Okay, so now we have to generate the state and nonce as well. And let's go back to that page here. This one. Right, so they're saying cryptographically random value as the session cookie, and a hash of that value is the nonce. Okay. So we're going to say const random val is the server's RNG, and we just want a random value. Oops, this is the random interface. Do we need to use random interface, or can we just use this thing directly? It does look like we do want to go through the random interface. Okay. So const random if is this, and random if. What options do we have on this thing? What options do we have? Bytes. Reasonable. What is like my words? So I'm probably, if I'm giving like a session cookie, what can go in there? I assume there's like some limit on what I can set, right? I can't just give it like literally any bytes, because like those bytes could have /r/n in them. So I assume that there's some sort of like valid set of characters that I'm allowed to use. And I think that probably it makes sense to just generate some random thing and then base64 encode it. Probably. I don't really know like what kind of like range is reasonable for this. But maybe we'll just go from like, let's think, 32 bits. Like how much entropy do I need? Yeah, that seems fine. Let's just do that. I don't know. I'll have to like revisit this. Revisit how much entropy we need. So we'll do something like fix me. How much entropy do we need? And for now, we'll just say random int u32. Let's just get a random u32. I guess a u64 is safer. Let's just do that. So we'll call this the random val. And then our hashed val is going to be our stud crypto. Is there hash 2? Like, can we just do like a SHA-256? Looks like it. Fuck. And how do I use this thing? This is called this hash function. So this is the input, this is the output, and then there are options. So the input is a random val as bytes, stud mem as bytes. The output is I guess we need a const or var hashed val is some. Okay, let's alias this. Let's say const SHA-256 is equal to this because I don't want to fucking type that shit show out every fucking time. We're gonna say that our hashed value is an array of SHA-256 digest length. Yep. We're going to hash the thing into the hash val. And then we have our hash val is the nonce. I think that they let us use the same thing as the nonce and the state, so like fuck it, we'll do that. That's what all the examples do. I think they're like technically different but kind of the same. Like they have like different attack schemes, but they're very like you can use the same verification mechanism for both. Oops, sorry, I just smacked my mic out. That didn't like deafen you guys. Okay. Okay, and then we have to shove this thing in there. So this is we need to base64 encode it as well, right? So stood base64 do I URL safe? Fuck it, standard. Do I care if it's URL safe? I guess it's safer. Sure. Encoder encode from. I guess we need to know how big the output is, so we can do encoder calc size of this. And I bet you, actually, this is compile time resolvable. Dude, Zig's so fucking cool. Like, I bet you that this function can be called at compile time because... Oh, no, this needs a const base64 encode. Oh, no, yeah. I bet you that this will work at compile time, which means that I can probably say that the base64 encoded is this. Which would just be so fucking cool. Because then we can just say that we are encoding from dest to source. So dest is base64 encoded, and we're encoding the hashed val. That would be very fucking cool. Very fucking cool. And then we can just pass in base64 encoded here. Yeah. Blaze it. We need to put a little ampersand in front of this guy. Fine. To coerce him from an array into a slice. Value of constituate ignored. Really? Oh, I see. That's fine. Yeah. That's so cool that fucking works. Login. And we got a thing. Nonce that looks like a new value, and if we go back and we refresh, we go again, we do hopefully get a new nonce that looks new. Looks new, pretty cool, pretty cool, pretty cool. And then what do we want to do next? We need to set the session cookie to the random number. So I think it's just like set cookie, set cookie. Mozilla. You can tell I'm not a web dev because I like don't know what the fuck is going on. So they said something about a session cookie, HTTP only. I read all of this the other day and I can't fucking remember. So what does secure mean again? I obviously want it to be secure, but what does it mean? Indicates that the cookie is sent to the server only when a request is made with the HTTPS scheme. Oh, okay. Sure. Session cookie. Session cookies are removed when the client shuts down if they do not specify the expire or max age. So they just do that by typing session ID equals. Is that like just like by convention? They just have like a convention like by name. Weird. Oh, I guess like how am I supposed to know? Okay. Yeah, cookie name equals cookie value. So they just have its. No, it's by not including expires and max age. Oh, I see. Thank you. That makes more sense. Any takes on using Firebase for auth and Store for storage? My takes are, what the fuck are either of those things? I'm like not from the web dev world, right? And so I think that like the web dev world, from my understanding, my impression of it from afar, is that like it's a bunch of like JavaScript developers, right? And like JavaScript developers are kind of used to like making a website that runs in the browser, and they're really good at that, right? But that I think that like my impression from what I see is that like what code gets run on the server is like less of a concern. And so in my head, it's like, I want a database. I'm gonna like run a database on a server somewhere, and like the server is gonna be in my house, and like I'm gonna run SQLite, and I'm gonna like I just like know I like knowing like exactly where everything goes. But I think that like people who are like, well, I just want to write a website and I need some storage somewhere, they'll like use some service for that, is like my understanding. Maybe I'm like totally off base here. But like, so I would just like the concept of using some external cloud provider for my storage that I have to pay money to. It's like, why the fuck would I ever do that when I just like I can just stick the database on my hard drive that I know where it is, right? Like, but like I can totally see why somebody not from the like somebody who's just like, I write JavaScript client code and like where the fuck does the files go? I don't care. I just need them to go somewhere. Like I can see that argument as well. And maybe I'm misrepresenting their argument because I don't know what the fuck other people are thinking other than me. Yeah, we pay a lot of money to have Microsoft run this scale server. Yeah, I don't understand. I kind of get it. So I worked at a company where we were kind of like, we had this like room full of like neural network training machines. But we didn't have like an IT department or a DevOps department or anything, right? And so like it was just on me, like whoever like who happened to be like using the server to like maintain those things. And so like I spent like 2 days one time just like trying to figure out why this server was occasionally crashing, and so spending time doing like mem tests and stuff. And like I can totally see like, when I'm sitting at my fucking desk like lugging a fucking heavy server back and forth and like taking it on and off the rack, which requires like 2 people and a drill, and it's like I can see why somebody's like, I just want to fucking do my job. This is a waste of money. Like it's not even like a waste of money, it's a waste of it's not just a waste of time, it's a waste of money too, right? Because like you're spending like developer salary on like running memtest. Like I can totally see like the appeal of a company spending money for another company to do that for them, so that their like engineers can spend time doing engineering. But I would never do it. One of the greatest bamboos of the century was that cloud providers convincing everyone that running a server is rocket science. I think it's more that like once you hit a certain scale, you need someone full time managing it, right? Because like things will fail, and past a certain threshold, you just need someone to like put out those fires non-fucking stop. I would think. It was also nice if you don't know if anyone is ever going to use your stuff. Yeah, if no one's ever going to use my stuff, then my server can like be a rock for all I care. If I was to call the shots, I wouldn't do it because I enjoy doing that kind of stuff. Yeah, I think that's like a special type of person. One of my friends, he spends a lot of time like buying hard drives and putting them in like a server that he runs under his desk. Just like he's just like, I've got like 100 terabytes of storage, and you're like, why? And it's like, I don't know, just store stuff on it. It's like, okay, like if that's what you like doing, that's what you like doing. He's like, I just need to like find something to store on it. Like he doesn't have any data that he actually wants to store, so he's like looking for reasons to just fill up the disks so that he can manage his server. I'm like, that's so funny. But I'm not one of those people. Looking at hey man, just watch a bunch of your terminal EGUI streams. Any reason why you didn't use cross term? Any reason looking at building something similar? Cross term. I just lets you make text-based interfaces. I assume that this isn't what I wanted. So, having Googled this 1 second ago, right? It looks like that this is kind of like an ncurses equivalent, right? So you have a terminal program, and it is being displayed in a terminal emulator, and you need to like execute some amount of like terminal commands, right? So you're like, you want to be like, hey, I want to like put some text over here. So like in Vim, for example, when I move the cursor over here, it needs to be like, hey, terminal, could you put the cursor there? Because the terminal's in charge of the cursor. I was making the terminal itself, right? So I would have to parse those commands and execute them myself, and I don't think cross-term is that. But I could be wrong. Either way, the point of these projects often is to like fuck around and figure out like how do these things work and like what are the pieces of them and stuff. And so kind of like using a library to abstract that stuff away kind of defeats the purpose a lot of the time as well, which is not a recommendation for you to have not invented here syndrome in the real world, but on this stream we heavily embrace not invented here syndrome because it makes things more fun. Okay, so we were setting a cookie somewhere. Was this the only browser? I opened a new browser. Okay, so we were going to set a HTTP only cookie like this, and then we want it to be a session cookie which says that expires and max age are unset. So we want something like this, and the cookie name is I guess we can name it whatever the fuck we want. So we'll just call this nonce val nonce unhashed. Sure, and then this needs to have a value associated with it, which means that we have to do a buff print. So we'll say that the set cookie stir is, or buff, I guess, is a, you know, how many bytes do we need for this? We could probably calculate this. The unhashed value is a 64-bit integer whose max value is 2 to the 64. So calc 2 to the power of 64, which is 19 digits, it looks like. 19 digits. Sorry. We want, oh, but then we hash it. So this actually doesn't matter at all. It's just the SHA-256 digest length, which is 64. Digest length, digest bits. Oops. Digest bits. Oopsies. Is, oh my god, it's up here. 256 over 8, so 64. But then base 64, so 64 times 4 ish. I think. So 64. Oh, the cookie's unhashed value. That's a really good point. I did write the word unhashed like 30 seconds ago, which means that we are back in integer land. So this is it was 19, 20 bytes. Once we turn into a string. So this only needs to be like, you know, 100 is plenty. Because I don't want to count. Good point. Thank you. Const set cookie val stood format buff print this shenanigans. Boom. This gets printed into our set cookie buff and with the value of random val. And then this just gets set to set cookie val. Okay, so we go to this place, we set this cookie, and our nonce is in the thing. So probably that's all we need. We're actually kind of on this at some point. So we started this like a long time ago, sometime way before 53 minutes. Okay, generate nonce cookie and redirect. Maybe that's it. Let's double check. Fuck. Right, because I wrote const on a thing that I'm modifying like a fucking dumbass. No space left, so we have to like try here. I guess that we should say we could like catch panic cookie buff length too low, right? Because like this returning an error is like insane. This is like a programmer error if this doesn't work. So just fucking crash and burn, baby. Okay. So go here, log on Twitch, and now I would like to see is this Twitch login thing should have asked us to set a cookie, right? So the response header should have set cookie, and so now can I like view cookies for a website somewhere? Right? If I just like go back to my website, can I like see my cookies somewhere? Storage? Cookies? Not unhashed? This value? We should have like looked at what the number was. Let's like maybe write it down so we can check. Std debug print. Random val is this. I like that I'm like so lost that I like need to. I'm like, what the fuck is a cookie and where does it go again? Like, okay, so we're storing this, and if I go back here and we try to look at our storage, we should see this number here, which I do. I think those are the same number. So, hell yeah, HTTP only, secure, false. Does this say expires session? Seems good, man. What does seam site mean? Do I need to worry about that? Sounds like something I want to worry about. Okay. Same site. Controls whether or not a cookie is sent with cross-site requests. So by default, does it say what the default value is? I thought that I looked this up the other day, and I thought that I saw it was default. Oh, default lax. Means a cookie is not sent on cross-site requests, such as going to load images or frames, but it's sent when a user is navigating to the origin site from the external site. So this is exactly what we want. Because when somebody comes from Twitch's off page back to us, we need to make sure that we have the cookie. Should it be secure? I think that since we are navigating to an HTTPS site, it shouldn't matter. And we are only going to, actually, sorry, we can't make it secure because our website is only served over HTTP right now. And we are going to fix that later by putting Nginx proxy in front of it so that it'll be HTTPS in like production. But I think that if we make it secure, I think it won't work. So I think that we'll leave it as unsecure for now. Okay. So yeah, it feels like that's it. That's all we need to do. And now we just should be able to like get the code back and like do something with it. Probably. I don't know. Don't ask me. I'm just here. Okay, so if I hit authorize, we come back here with this code and we go like, that's not something that we know how to deal with. But we can just start implementing this now. So the fact that this doesn't go to like login or something here is probably a bit of a problem. But for now, we will ignore that, and we can configure that later. And so we'll just kind of assume now that if our URL starts with a question mark code, we'll just start handling it properly. So how do we want to do that? Maybe we will give it like a, login redirect as a possible thing. No, because we can't string to enum that. No. How do I want to do this? How do I want to do this? So here, instead of returning not found, I guess we will try to see if it matches. Oh, that's gross. I almost want, I guess we could just parse the URL ourselves, and then it becomes simpler. So here we will say, login redirect is like a thing that they can send us to. Or maybe we'll call these like const. Yeah. That's what we'll do. Is we'll have like URLs as well as like response purpose. Response purpose. I like that. And then we can just give these things normal names like index, login, redirect, and code. Fuck it. And then we will like do this thing here, and we'll like generate the purpose from this. We'll say if our URL successfully parses, we can maybe say that this will give us like a parse purpose or something. And like if it matches any of these things, we are good to go. So maybe we should actually do, maybe put this externally. I'll do it inline for now because I don't want to move all these structs around. So we'll say const parse purpose is equal to a struct with a function f that takes in a target URL and returns a response purpose. Okay. Then we can kind of like invert this. We can say if this succeeds, we have some sort of URL. We can map this to a purpose. So we can say which URL, if it's this, that is a index request. And if it's Twitch login, it's a login redirect. Yeah, and then we forgot to close this bracket here, or this parenthesis, I should say. And then we forgot to close this one as well. Okay. This comes from target here. This, and then if this doesn't succeed, then we can start doing our like more advanced parsing. So we can say, if target stood mem starts with a U8 buffer, if it starts with like this, what does the @ sign do? This basically says like, hey, I'm gonna make like, if I were to say like const x equals 3, right? This means that I have a variable x I can use. If I wanted to put, but there are like some characters that I can't put in here, right? Like I can't do like const 3 equals 3 because it's like 3 is not an identifier, 3 is a number. But if I say @ sign and put a 3 here, now all of a sudden I can put anything that I can put in quotes as like a variable name. And so what that lets me do is if I have an enum like this, where I'm just putting like URLs to places, it means that this is actually just a number, right? This slash is 0, and this login is 1, right? But it means that I can do metaprogramming in Zig to say like, hey, I have a string. Could you check if the string name matches the name of this enum field? And because I can now put slashes in there, I don't have to do any like stripping of the thing so that it matches only identifier valid tokens. I can just be any fucking string. Any fucking string. Which is kind of nice. It's kind of nice. So it starts with which side? It's haystack, needle on the right. So the needle is our target. So if we start with this, then we can say that we are in our response purpose code. And otherwise, we return null. And now I replace this URL thing with a purpose. And we say parse purpose with the same target. So is parse purpose. Boom. Boom. And then here we replace this. This is now index here. This is login redirect. And now we should have a new one for code. And for now, let's just std debug print got URL, and we log the target here. I think it's like this, all for your target. I can't remember where we put it. I need to do more Zig, but in my current projects, I already use Rust. I mean, I would say personally, if you're happy using Rust, I think that like need to use Zig is you don't need to use any program. Like, how to say this? Zig and Rust fill a lot of the same niche, right? And so it's like, I don't know if you really need to. I think Rust has more staying power at this point in time, but Zig's pretty fun to write. So it depends on like, just really depends on what you want to do, I guess. If you want to write more Zig, that's chill. But I wouldn't feel like a strong need to if you're not writing it naturally, you know? Okay. So this did jack shit. So why the fuck not? Why am I not getting here? Can we maybe print? Maybe I made a mistake. Maybe we made a mistake. Refresh? Hello? Why? Oh, is it? Am I? Oh, oops, I want to do it here. My bad. My bad. Refresh. Okay. So this does start with /? So I don't know why this parse purpose is not doing what I want. Right? Like, should this not be... Here, we'll just write here. Matched. We matched. Wrong arg order. I'm looking for... Oh, maybe. I could see that. I guess I thought that haystack was... Yeah, you're right. Haystack is the thing I'm searching in, which is this. And I'm searching for this thing. You're right, you're right, you're right. Thank you. There we go. Yeah, thank you. Good eye, good eye, good eye. Okay, so now we need to, I guess, just parse out the query params. So, I don't think the standard library gives us anything to do that with, but it's pretty easy to write one ourselves. So, const query param iterator, and he is going to act on some target. And we're going to have some sort of next function that takes in ourself parma iterator. Fuck it, why not? And he's going to return some sort of like param. And then we are going to say that we have like a parameter output. And he's just going to have a key, which is a constituate and a value. Chill. There are two ways of doing this. We can reassign the slice as we move forwards, or we can like store an index. I'll probably just reassign the slice. Fuck it. So we initialize this thing with some target, and on start, we're basically gonna look for the first. We're gonna look for the question mark and start there. So std mem index of the target. Index of scalar, I guess is fine. We're gonna look for this question mark. And if we find the question mark, then we have some query params to parse. Big win for us. And so we just say, I guess this can fail if there's no, maybe we'll say null. If there's no question mark, then there are no query params. And I think that's okay. Or we could even just give it like an empty slice, and then we don't have to handle anything special. I like that. I like that. Is there something like the clone command in Zig? Like there is in Rust? So yeah, whoever's saying you don't have to clone in Zig is, you're kind of right. So like the concept of, how do I say this? Because in Zig, there are no destructors, right? There's no like RAII, which I think is like the dumbest name of all time. But there's no like, there's no automatic destruction of things. So when you go to scope, you're not going to run dinit. Like, I have to manually call dinit on something to free the memory. And so if I'm manually freeing the memory, copying a vector around, I can just mem copy all the fucking time, right? If I want to do a deep copy, we just write the deep copy ourselves. And if we want to do a shallow copy, we can do that without worrying. There's no like concept of like movement or anything like that. Which makes for things a lot simpler in some ways and a lot more complicated in other ways. Two-step is saying that there is something in URI parse. Last time I looked at this, I didn't see what I want. Oh, query is component. So if I look at a URI, I'm on a URI now. The query has the raw characters as percent encoded, but neither of these are really like key value iterators, right? Like if I want to extract a specific key from the query parameters, it doesn't look like it gives me that. Unless I'm like fucking stupid, but I don't think that's in here. So I think that writing this is still what I want. I think, but we'll see. So this will be or else. I guess we will just say target len. Yeah, that's maybe not valid. I was gonna say that like we could do const index is here and then return this with target is equal to target idx dot dot like this. But I think if I make idx target len, then this is going to be an out of bounds access, which is illegal. But then it would have been nice because it would have been like a zero size thing. So, but what we could do instead is we could say const. I would like to return like a zero size thing in the case where it's not found. So I guess I will just return here. Like this. We can just actually do like something like this. Fuck it. Then otherwise we do this. Chillin'. Okay. So on each iteration, we are going to look for the next and sign. Is RAI the same as RC arc? No, RAI is resource acquisition as initialization. Yeah, I mean, that's technically what it stands for. I think that people just use the word RAI to mean destructors. That's been my, like, colloquially what I have seen. Because, like, but, yeah, it is actually more about, supposedly, about acquiring resources on construction. It's destructors both constructors and destructors. Yeah. Okay, so this is where like the next thing is, and I guess this actually had to be +1. This did have to be +1. Or we'll just say that we start at the value the index before the key. Yeah. Okay. So I guess we just start at the beginning and we say if target len is less than 1, less than 2. Return null. We are done. We are donezo in that case. Otherwise, we have the key start is equal to self. It's just 1, the first index, because our target is looking like something equals something, right? We are here, so our index 1 starts here. We look for an equals key. We'll call this key end is find this thing, or else we return null. If the key end is +1, i.e. value start, if value start is too far, we return null. Nothing to look at. And then this is value end. If this is not found, if we don't find an ampersand, then it's just the length of the thing. Yeah. Yep. And so then we have just return. Key is equal to self target key start to key end. And the value is value start to value end. Easy. And we need to defer idx is equal to value end. Sorry. The self target is equal to the current target from value end onwards. Which means that it will be either the length or the ampersand. And so if we are at target length, this will probably crash because value end is out of bounds, which means that we need to do a check there. If value end is greater than or equal to self target len, else this. So in this case, we just do self target is equal to an empty thing. There we go. Oh, so now we want to, we were doing this because we needed to look at the query parameters. So let's just go into our thing where we got some URLs and fucking look at the query parameters. So it is equal to query perma it of this target. And well, we say while it next val or param, I guess. Let's just print the parameter. So this is just gonna be like param any and param, baby. He doesn't like this because no field name value. Really? Is it val? It's val. Does Zig have Rust overflow checks of arrays? It has like this like concept of compiling in safe and unsafe mode, or safe and fast, I think is what they call it. And so in safe mode, it will crash on out of bounds array access. But in fast mode, it'll just do what you do in C, which is like a nice choice to be able to have if you're like certain. Start index is 7, larger than the end index is 0. So this is coming from target value start value n 350. Really? I guess we just fucking GDB this thing. Because that is not expected. Not expected at all. So 8. Self-target is this. Great. 7. 0, 1, 2, 3, 4, 5, 6, 7. Yep. Defer after constructing return. I think that the defer means that it shouldn't run until later. Yeah, I don't understand. I don't understand. He does have a length of 66. Oh, value end is 0. I'm high. That's the problem. Why is value end 0? Oh. I see. I see, because there's a 1, there's an and right at the fucking beginning where we're sitting. So this has to be 1 onwards and then plus 1. There we go. That should fix it. Here, let's do this. That makes it all work out. That makes it all work. Okay, so now we got to the end. We got our keys and values. We got 2 query parameters, 3 query parameters even. And I don't like the way we're printing them, so let's put them a little nicer so that we can actually see what they are. Make sure that we are parsing correctly. So this is param key, param val. Boom. There we go. Nice. Nice. Okay, so now we have our code. And with our code, we are supposed to reach out to the authentication server. That's what we're supposed to do. So we're supposed to go to this thing here. We're supposed to do this essentially, where we say, open a terminal and exit the following post. Yeah, so we do a URL encoded post to the authorization server. Perfect. So I'm just gonna do this inline for now. We kind of set up this event system yesterday to make sure that we could like do this asynchronously, but I'm not really worried about that quite this second. Okay. So we're going to make a std HTTP client, probably. How the fuck does this thing work? Let's look at the website, I guess. Okay, what is this thing? I've never used the HTTP client before. Connections are open in a thread-safe manner. TLS support is available for us, and we just connect with some clients. We have to make a client somehow. Does the client... looks like it has a lot of default values, so I just have to make it with an allocator. There's no... init default proxies is probably what I want, I guess. Sure. No, because this is takes a client. So it looks like we were just supposed to just shove the allocator in there. So it's just like allocator is equal to self server alloc. Boom. And then we should be able to go like client dot connect to is the host. Does that take a name? Does it do name resolution? I don't want to have to do the name resolution myself. Host : port using the specified protocol. So let's just try, I guess, doing this. 443, I guess. And then TLS, I guess. Is this a failable thing? Try const connection is equal to this. Defer connection dot dnit, I assume. No. Okay, that's fine. Defer client dot dnit here, I guess. So I see, this is giving me a reference to something that's stored in the client. Got it. Let's see how that does. I don't need to run a GDB right now. That's fine. It's fine. Wow, he's thinking hard today. What's going on, buddy? There you go. Okay. So TLS initialization failed. Surprising. Surprising. Zig, TLS, and some examples here. Maybe I am not using it correctly. You're saying it's an HTTP test. So if I go to here, I should have. You're saying an HTTP test. So if I go stood HTTP test Zig here. Fuck. I guess we will go to the actual Zig source code. I'm on the wrong version, which is probably a problem. Git checkout 013.0. And let's go look at the center library. Okay. Client. Okay, so they did do the same thing I did here. Client connect. They don't call this anywhere. That's fine. Zig only supports 1.3. Might be a TLS 1.2 issue. Can we check that in some way? Probably curl. Curl -v. Like, can I do this? Something like, is it going to tell me? What this looks a lot like it. We try 1.3 and then it downgrades us to 1.2. Is that what this means? In which case, I guess we just use libcurl instead of using Twitch's built-in support, which I think is fine. It's fine. We can make that work. Let's just say that we're on a detour then. At 01:23:30, we'll call this HTTP client with libcurl. This I have done before, and this is probably why. Libcurl easy example. Libcurl example, simple C. Perfect. So they go like this. You perform the thing. I want a post example. Although probably they have more examples here. Post. Boom. Simple. Easy. Yeah. Okay. So I guess we just need to add curl to our development environment. And do we have any C imports in this project right now? I don't know. I guess we have it in user info already for OpenSSL, but I think we're limited there. So we can just tack onto that, I guess. Where's the maze? I sometimes if I feel like I have too much things to write on the side, then the maze gets booted. But it'll be back. It'll be back when we have less to write down. Okay. So what do we need to include here? Curl. Okay. curl.h. And we'll call this HTTP client. And he is going to... In Windows, this starts, and it's the WinSock stuff, so I guess I just don't have to do that, maybe? We'll say curl is a curl. You have to yell it. When we initialize this thing, we need to return HTTP client. Still magic to me that Zig just lets you import C like that. I will say that this is probably my favorite thing about Zig, is it's like C interop is just so fucking nice. It's so nice. Okay. Const curl is equal to this, and probably this is failable, so if curl is equal to null, I guess we can just write or else here. That's nicer. Or else return error internal error. I sound like I was so like deficient. It's like when I talk to my dog. All right. Let's I guess compile this thing because probably we need to do something like link system library curl build. I guess there's a chance that this won't run until I like actually instantiate that client, but looks like it's working. Okay. Okay, so let's do get. I guess we want to do post. That's what we're supposed to be doing. And the post is going to take a URL. He's going to take in a client, which is ourself. And he's going to take in, you know, some data. Okay, and then we just do curl easy set opt. And it was C. I guess we'll just fucking copy paste it. That's easier. Bump, 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 bump. These come from self. It comes from the C imports, and this comes from URL. This comes from data. We have to do something with the thing on the way back. So I think you have to like specify a callback in here or something. It's kind of funny that these examples don't show how to like do anything with that data. But post callback. There we go. This is a better example. So we give it a function. So we're going here. This is the read function. Is this like we get some stuff from curl? Slowly test data post. Where is that used? Data. This is the other way. Fuck. This is like providing a function that curl calls to get data to push into the buffer. That's not what we want. We want the other thing, which is like when you have, I guess it would be called write data. Would be my guess, write function. So in this scenario, yeah. I think this is it. Is this how you're supposed to get data from response? I think compiling Zig HTTP client with his TLS causes slowdown. You notice? Oh, interesting. Because it's like it's got to pull in all that crypto stuff or something. Curl easy get response body. This is what I want to know. Get output into a string. Yeah, that's all I want. That's all I want. And they did get us to where I just was. Write function. Okay. Sure. Sure. We can figure this out. Where is our write function example? Examples? Write function? write callback used to download a chunk of memory and storing a file. Sure. So they just register write function and write data. And then I assume that this just gets us a size and content, size, number of elements, user pointer. And we can just fucking copy that shit in there. Okay. Okay. Yeah. So is this the write function? This is write function, write memory callback. Write memory callback is this. Okay, so we just need to copy this function. We will say, boom. We need to make sure that this returns a size. T is going to be a usize. We're going to use call conv c because we are passing this function pointer to C memory. We're going to call this write callback, and we're going to start saying that we have like contents is any opaque size, usize, num emp usize, user data, any opaque. And I guess what we can do is we can just kind of say that our user data will be like an array list, and we'll just like copy the shit into an array list or something. So let's do this. Const write callback is equal to a struct that has this shit. We'll call this f so that I don't have to write callback twice. And then here we should be able to pass in this thing as a curl opt write function. So this is like this. C self curl. Did anyone know the resolution to the compile time issues we had way back? I think that was specifically related to like the Rust library being like so unbelievably large, right? We were trying to like link in like a 150 megabyte library, and when I was like s tracing it, it was pretty bad. Like it was how to say this? Like Zig was doing several copies of the final binary. So we were like linking the thing statically with a big size into an executable that we were copying twice or something like that. And so the fix, like you can like dodge that issue with dynamic linking in debug mode at least, which was what I think I ended up doing. Because like in release mode, you can tank that hit a little bit because you're already you kind of already turn on like LTO and shit. You kind of say like release builds will be slow, but they'll run fast. But debug builds should be fast and run slow. Okay. So then we need to set our user data pointer to be our array list. So here we should be able to say, I want to do, return red. Output, man. And then we'll say var output is a std array list of U8. With some allocator. I guess we will pass in an allocator here. Boom. And then this probably has to be a pointer. I'm a little worried about this write callback. I don't know if this has to be by pointer like this. And since this is a variadic function, then like getting it wrong causes all sorts of like bullshit problems, but it's okay. Okay, then we've done curl easy perform with self curl. And here we just have to start doing something. So we say, I guess we should type def this thing so that we don't fuck up our casting. Type def, what am I? A C++ developer? Unbelievable. Unbelievable. So var output is equal to a output equal to pointer cast, a line cast of user data. Boom, boom. And then we should just be able to be like, how does this work? Real size is this. Yep. And then we just say, can we take contents? I guess we say const contents U8 is equal to a U8 buffer, which is a pointer cast of contents, probably. This might have to be a line cast. I don't know. We'll see if it complains. And then we should just be able to be like output dot append slice contents u8 from 0 to real size. I think that should be fine. And then we'll say catch panic. Uh-oh. 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 And then probably after all this, we can just return output to own slice. We could probably flag the failure somewhere. We'll get there eventually, though. This is just a bunch of U8. Okay, so now we should be able to construct our HTTP client and use it, and it'll crash, and it'll burn, and we'll fix the problems as we go. So this comes from HTTP client, init, boom, boom. We can try this thing, and then we just client post with our alligator, and we post to this. And we post with line 36 don't have track keyword. Thank you. I'm sure that it will I will find that in a second anyway, but thank you. So we'll call this data is equal to this, or response is equal to this. This probably has to be tried. And then we need to probably defer self-server alloc free response. Sure, fuck it. We need to put some data in here. So I guess we'll just kind of like yoinkies this shit. And I guess we have to buff print this. So we're gonna say, I guess we'll start here, and it will like be like, hey bitch, that's a bad response. And we can kind of fix it from there. I would prefer to see that like we have something, like we're not like fucking crashing, so we can kind of like limit the scope of what we have to think of at any given time. So this has to be pointer, which means that the URL kind of has to actually be null terminated. Data probably also has to be null terminated then, because this is going into like we're not giving this thing length, so it must be null terminated. Value ignored, so let's just kind of like hard ignore everything. This thing returns a U size, so we just return real size, I guess. What did they return in the example? Yeah. Okay. Let's see how fucked it is. We did get to this panic at the end. I should have printed out the response. Maybe it gave us something. Std debug print response. So we'll call this Twitch said this thing. Let's go, baby. Oh, that's sick. Wait. First fucking try. Let's go, baby. Nice. Nice. So we got like a, totally reasonable response from him, which is sick. So now all we have to do is we have to like construct what is a sane response out of this guy. But first let's deinit this thing. I assume that after some amount of time we have to free our curl shit. So I'm assuming that in here there's just like a curl easy cleanup. And this comes from self curl. Boom. Which means that this deinit can come back. Nice. And now we just have to, make a request. So const rec buff is, 1024 U8s. We will buff print rec data, I guess we call it, is a std format buff print of this shit. Like this. This is going to be our client ID. This is going to be our client secret. Our code we have to get from the query parameters. Grant type is hard-coded. Redirect URL is 8000. Okay, and so now we just need a self server client ID, self server client secret, code. And we just have to now extract those things. But then when we send this thing, we just be like, this has to be buff print 0 actually, buff print z, because we need these things to be null terminated. Then here we can just say rec data. Boom. Okay, so code, we just need to say here, code is going to be a something like this. And we're gonna walk our parameters, and if param stood mem equal param key and code, then we're chilling, and we can just set the code is equal to param value. Boom. If we have no code, we get fucked. So here I'm gonna actually call this code opt, so that I can rename it code later and not worry about the optional shit. So I guess we'll just say const code is equal to code opt or else. Or else we return error no code or something. I don't give a shit. Okay, this buff print has to go into the rec boof. We have a code, we have a client secret that we need to get, so client secret. We are just going to leak, and you guys are not going to use it. Please. Please, guys, just please don't use the client secret, pretty please. But even if you do, I'm going to regenerate it post-stream anyways, it doesn't fucking matter. But don't do it. Like, don't, please. Yeah, here you go. Don't fuck with me. Okay. Okay. Dude, Urine Luckboy is an insane name. That's disgusting. Oh, it's a pun. It's less disgusting, but it's still gross. Alright. Might work. Wouldn't surprise me if it worked. But maybe it surprised me a little bit, but not that much. So we need to coerce. Really? What am I coercing? Client ID, code. I don't understand which of these things I have to coerce. This is a slice, also a slice, also a slice. So all of these things should be totally fine. Oh, the rec buff. It tricked me because it is aligned correctly here. Right, like this arrow is pointing at rec buff, but it looks like it's pointing at client ID, and that's confusing. But they are reasonable. Is print buff Z for null terminated strings? Yeah, exactly. Or not new line, null. You type \n is new line. You mean maybe \0? I don't know. Is Zig strings different from Sig strings? So I think that like if you type in a string in Zig like this thing is null terminated. But like generally your slices do not have to be null terminated. So it's like Rust where you have like fat pointers where like your slice is a struct that has a pointer and a length in it. And so like in reality, in most scenarios, you don't actually need that null terminator. And it's just extra data that you don't need. So that you don't use it most of the time. But sometimes when you're interrupting with C, you do need it, so you do it. You know, this thing needs to be variable. I make this mistake all the time. Here we need to write try somewhere here, I guess. And we're chilling. Okay, so if I go here now. Oh, it's so fucking sick, man. Hell yeah, baby, we got the fucking right answer. We got the right answer. And now we can just kind of like plug this in to our existing parsing code. Parsing code. I guess our existing parsing code starts at the ID token, so we do need to parse this auth response. But that should be pretty easy. Should be pretty easy. So this is like, well, Zig strings have a count, I see. I mean, like, I don't know if I would even really call them Zig strings, to be honest. I don't know, like, I guess that they are strings, but like, it's kind of just like a bucket of bytes. Like there isn't like a string, like in Rust. It's just like some bytes, and it's like in C by convention your strings are buckets of bytes with a null terminator. In Zig, by convention your strings are like a slice, I guess. Access. I guess the only thing we care about in this is ID token. So even like making this type is probably pretty silly. It's probably fine. ID token is going to be a const u8. And everything else, I probably don't give a fuck about. Because we're not actually doing any access. We are only using this ID token. So we have like an authorization token and a refresh token, but we don't really care about those because, the refresh token is only to refresh the auth token, and the auth token is just going to go away. So I think we're chilling. I think we just need the ID token. Okay. So over here, wherever the fuck we just were, we should be able to stood JSON parse from slice into a auth response. We are parsing the response, and I assume we need to give it an allocator. And we need to give them some options, and the specific option I care about is the one that's like, hey, if I have extra fields, don't give a fuck. Perfect. So now we can defer parsed dinit, probably? No? Try? Probably try. Then here I can dinit. Nice. Nice. Zig also has sentinel terminated pointer slice types such as :0 conjugate, which basically says like, hey, make sure that you put a 0 at the end of this thing. I don't really understand. Are there any uses of sentinel terminated pointers other than null termination? Or is it like is it just generic for the sake of being generic? Or is there a real reason why you'd want a sentinel terminate with anything else? you know? I guess you could like kind of use that as like a trick way of implementing dynamic arrays instead of keeping a count yourself. You have like, I have the values 0 through 100, and so if I use C101, I can use that to flag the end of an array. :69 const u8, perfect. Yeah. Because you want to 69 terminate your arrays, of course. Okay, so now we should be able to say that we have our ID token, and all of our parsing before, we can probably verify that ID token with this stuff. Yeah. So what do we do here? I guess we put these RSA parameters that we pulled from Twitch into our server so that we can look at them later. And then we can validate the token with our RSA params. So here we just say, we got a web token here. And I would like to look at them, please. Yeah. So here we just say, I would like to look at parsed value ID token. We have our self server RSA params that we can use to validate the keys. And then we can just print out what the fucking thing was. Yeah. Cool. And if that works, then we are in a very good spot to like actually log our user in. This clearly won't compile because I didn't ever set the RSA parameters down here. So RSA params, let's go RSA params items like this. Expected this, found that. Am I stupid? This needs to be a list of them, right? Because there might be more than one. They might give us like 5 keys that they could decode with, and then the header of this token will tell us. If we refresh here. Error missing field. So that must be here. So our auth response is supposed to look for an ID token. What was our, maybe we should still say Twitch said this thing. Twitch said response. Did I fuck up? Is there like a Invalid auth code. Oh, because I've already used this one. Right, so I should just go through the proper fucking flow again. Login with Twitch. Authorize. Hell yes, dude. It says my name. Look at that. Hell yeah. Oh, that's so sick. Okay, that's pretty good. Pretty fucking good. Yeah, it's sick. Okay. Okay. So what's next? We need to actually like look, we need to correlate the nonce value in the response with the one that we sent out, which is in the cookie. So we need to, in our request look, we have the cookie. So we should be able to do like can we see what we did actually? How do we do this? Let's run our server. Let us go log in with Twitch, authorize. And then here, we should be able to see that we, hello? Oh, because he crashed. Fuck. Okay. So, let's for now just respond with something sane. So, can we just like, I guess we just make a response. So we just do this. We'll just go back to the index. Blaze it. Blaze it. Zig looks easier to learn than Rust. Would you recommend Zig over Rust? I think they serve, marginally different purposes. I think that I would recommend Zig if you are someone who likes kind of getting their hands into the nitty grittiest. I guess it's more of like a philosophy thing, I guess, right? Zig, I feel like it meshes better with people who like simplicity in some regard. But Rust meshes better with, I think, people who like how do I say it? It's like neurotic levels of consistency. like the idea that you can make an interface and like it's impossible to fucking break that interface, right? You make this fucking bulletproof perfect library and you give that library to someone and they can use it and you don't have to worry about them doing something fucking stupid because you handle everything in the library perfectly. And like you have like no unrepresentable states. You use the type system to make sure that like you go from type state A to state B, and state A is not representable because you wrote it that way. It's like it's so sick when you're trying to say that like I want it to be this way, and you can't fucking change it. Zig, you don't have that like ability. Like even the idea that in Rust you can like take in a type by value and return a different type by value, and the old type just like disappears. You can't use it anymore. You can't touch it. Like that's a very powerful mechanism, and you don't have the equivalent of that in Zig. And it lets you write some like very bulletproof code. But it comes with the cost of pain. Like it's harder to write Rust. I think that when I stand by that, like it's harder to write Rust, but when you compile it and it compiles, like the chance of it working is very high, shockingly high. In Zig, you see me hit segfault sometimes. You see me do some dumbass shit often, and yeah. So it just depends on like what you value. Depends what you value. You didn't get a rate limit yet? I was trying to say off with GitHub and got many rate limits. I mean, I'm not trying hard to avoid it, but I think I've made like 50 requests. Like I don't know. I would expect that I'd have to send a lot more before it's like problematic. Okay, so when we send our request, I'm assuming that one of the things that we send is our cookie. Cookie, yum yum cookie. And so we basically need to find that cookie and do something with it. So what do we have in here? We have like an HTTP connection, and he has a reader. And the reader, what does he store in him? He pulls out the things we care about. So maybe we would just want to store like headers. Fields, header fields. So I stopped storing this request head in here because This thing's like fucking like 300 kilobytes large or something because he decides that he wants to be very helpful. And if your body is gzip compressed, he like stores a gzip decompressor in there. And these things are just like fucking massive. And it was actually causing like noticeable slowdowns where requests were taking like hundreds of milliseconds to complete. And when I like benchmarked it, it was just like occasionally these mem copies were taking a really long time. So that's why I don't store this whole thing. I just like copy out the fields I care about. But it also looks like the fields aren't in here. We have method, target, version, expect, content type, content length, transfer encoding, transfer compression. And is there no like iterator of extra headers? No. So this isn't even helpful to me. So we just need to like walk the headers ourselves, I guess, on the request. I guess. Which means that we just have to like. Really? That sucks. Yeah, that blows. Okay. I guess we'll just do it here for now because I don't really want to do it in a generic way. I just want to like get the data I want. So here we can like basically split iterator. So split on this sequence. Yeah, so we can look at the self reader, no, inner reader header buff, and we can split on RN. And we can just walk this thing. We can just like rip this guy until we find cookie. Cookie. So we'll call this in header iterator. I don't know. I don't give a shit. Just fucking matter. Yeah, I think I have this right. So while in header it next, we have this like line, essentially. We're just gonna say if line stood mem starts with no case insensitive stood mem ASCII starts with ignore case. Hell yeah, let's go, baby. I know I saw it somewhere. So the haystack is the thing, so this is the line, and the needle is cookie. What was it? Nonce unhashed. Right? Yeah. If we start with this, then I guess we'll have like start prefix, cookie prefix. So we're looking for this thing. And then if we find it, then we have cookie prefix len. Yes. If this starts with cookie prefix. Then we say that the cookie val is line cookie prefix onwards, and we can stood format parse int of a u64 from this thing. Yeah. Why not? Base 10. Now we need a cookie val, and we'll do the same thing where it's cookie val opt is a u64 null. After all of this, we say cookie val opt or const cookie val is equal to cookie val opt, or else return error no cookie yum cookie. So my fucking brain is just like fucking melted with absolute fucking dumb shit. Okay, cookie val. So the cookie value was the unhashed number, so we have to hash the number again, which I guess is this stuff, and it's base 64 encoded. So we have to do like the inverse of this, I guess. So we base 64. Oh no, it's not base 64 encoded. I lied. The nonce is base 64 encoded. So we just have to do the same thing. So nonce from number. I think that makes sense. We pull this out. He gets a U64 in. He gets a bucket of bytes out of some known size. So, whatever the fuck. Base 64 encoded was this. Yeah. Sick. Const nonce size. I guess we will do this like this. Boom. And this was a stud crypto hash SHA-2. Boom. Okay. Okay, so now we can say we return a nonce-sized thing. And this is a bunch of U8s, I guess. And then nonce from number is this thing. So we take the value from num. We have to maybe say const SHA-256 equal this thing. Bum 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 bum. Bum bum bum. And then we just return base 64 encoded. And here we can now replace this with, oh fuck, nonce size. And nonce size should not be case like this. It should be nonce size to follow naming conventions. Okay. Now this stuff we can just say var not base 64 encoded. Down here is nonce from number with the random val. Boom. So all this goes away. And then down here, now when we're validating, we can just do the same shit. So here, we can say nonce from number cookie val. And we'll say this is the expected nonce. And that means that in the method, we can now look at our message. JWT dot value, what the fuck? JSON web token. What does this thing give me back? Oh, message. Nonce. And we should be able to say that the expected nonce is the nonce we got back. So we'll say std debug print expected nonce is this. And the received nonce is this. What is it again? I just lost it. It was JWT message nonce there. He's mad at line 569 about cookie prefix. Because of course that's wrong. This should be cookie prefix len. Okay. So we log in, we authorize. Oh, that's so fucking sick, guys. Look at that, baby. Let's fucking go. That is exactly what we wanted. Okay, so we now are pretty fucking set, to be honest. So what is in like this message, this JSON web token, JSON web token. So we now have tied the login back to this message. We've validated that like the message sure is from the same guy. We've validated his signature with RSA. We've verified that like we sent out this like chunk of stuff with this user and it came back and we like are sure that like this value that came back is the right thing. And so now like all we have to do is basically like we can just put in a database somewhere this like one of these fields in this JSON web token is like a unique identifier. I think it's ISS. Let's just double check. JSON web token. Fuck. Open ID token. Fuck. Where does it tell us? No, this is the URI sub. This is the ID of the user, which is different than the preferred username. So we can like put in a database now this like subfield, and just map it to username, and then every time this user comes to the site, we can just be like, "Hello, preferred username," because we have their key. I guess technically we should probably make a new cookie for them as well, right? Like a successfully logged in cookie. Or we could just use the nonce random value, which seems maybe not unreasonable. I guess the fact that it like stays around is probably bad. We should probably nuke it and give them something else. But yeah, I think that's kind of like all of the hard part done. This was like what, like a 3-day trek for us, which is a lot for something that should be so simple. But I'm pretty happy with current state. So I think our login is definitely working. Like, we're there. It's just now we have to do something interesting with it. So thanks for watching, guys. If you like what you saw, we stream most days at around 2 o'clock Pacific time. Right now, we are working on this Rube Goldberg machine, so maybe I'll pop open the demo again. Ball machine. So we are working on this project where we want to, we have these chambers that are defined by WebAssembly modules. The idea is that we will stitch these chambers together, the balls will run through them like a little maze, and users will be able to upload these WebAssembly modules. So we're kind of working on like the user upload part. Probably tomorrow, I think probably the thing that we'll work on is a like upload feature for this thing. So I think the interesting part is we want to do some sort of validation of, we want to make sure that WebAssembly modules don't take too much compute, they aren't too large, and they don't do anything like fucking stupid, I guess. There was a third thing, I can't remember what it was. But I think it'll be interesting to do some sort of like performance characterization of these things where we can say like, okay, let's run this WebAssembly module 100 times with 100 balls, see like where the balls come in, where they go out, make sure that like where we can like slot that in, stuff like that. So I think tomorrow we'll be back with like instruction counting of a WebAssembly module, which will be kind of fun. Yeah, if you're new here, there's a YouTube link in the Twitch description where all of our previous projects are organized by playlist. We're right now working on the Rube Goldberg machine, but there's other stuff in here: operating system, neural network, writing a terminal emulator, video editor, QR code decoder, zlib implementation. If you want to go check those out, they're there. Code for those things is also available on GitHub. A link is in the Twitch description as well. If you're watching on YouTube, there should be a Twitch link in the YouTube description. Feel free to swing by and say hi if you're online between 2 and 4 Pacific time. Like, subscribe, Twitch Prime, Twitch YouTuber things, and let's say bye to YouTube and Twitch. Let's figure out who to raid.